We're here to talk about depending on vulnerable libraries. First, I want to ask, how many people in the room are actually developers? Have actually write code? And I'm assuming of the rest of the group, well, another question is, how many people here are security professionals? No? Okay, so most of us security professionals, good portion of us developers, good mix. I'd like to see more developers. Just saying. All security people should learn how to code a little bit. So, a bit about me. I'm Jeremy Long. I've been doing information security for about 15 years. I've been a software developer off and on for 10 years. Huge fan of static analysis. SAST is just amazing technology. You can do so much with it. I'm a contributor to the OWASP Java Encoder project. It's one of the best, fastest encoders for preventing XSS. And I'm the lead developer architect for OWASP Dependency-Check, which we'll be talking about tonight. There's my information if you want to get in touch with me. So, what are we going to talk about? Well, hopefully most people here know why we should care, but we're going to cover it. We're going to talk about patching programs, what application teams can do to help out with the problems. We're then going to take a deep dive into dependency check and talk about a couple of usage scenarios and maybe a little bit of governance, just a little bit. So, why should we care? CVE from this year, Apache POI, information disclosure via an XXE, external entity expansion. This is information disclosure where an attacker can read files off of the file system and, you know, get an information that you generally don't want them to. Another one from this year, Adobe XMP toolkit for Java. Again, same thing. They can read files off of the file system and extract the data. Worse, again, earlier this year, if you're using Apache struts, which I know is kind of on the downturn, but we still have a lot of legacy code that's still running on struts. But if you had dynamic method invocation enabled, remote code execution, there's not much you can do about it. People would be able to execute code. And again, hopefully everyone knows about this one from 2015, which was a remote code execution within Jenkins related to deserializing objects using the Apache Commons collections. How many people actually know about that one? Yes, some people. Basically, this is exactly what we're talking about. Jenkins was built using a third-party library, Apache Commons collections. They had a method to read and deserialize data. If you read the documentation, it basically said, don't ever deserialize untrusted data. But who reads the documentation? So they went in and, of course, Jenkins deserialized untrusted data. And as we go through, we'll find, if you go back and research this specific CVE, there's actually, it spawned several others, all related to Apache Commons. And in the case of Jenkins, internally, there were so many systems that needed to be patched because, again, it's hopefully internal, nobody's putting Jenkins on the internet, but people were able to just execute code on those servers. So it's a dependency of Jenkins, kind of led to a little bit of a vulnerability. It's close with this one, just because they didn't read the API and they were doing something wrong, but the end patch did end up being in the Commons collection. So, Black Duck is actually one of the commercial solutions in this space. They had a great paper that they released earlier this year titled The State of Open Source Security in Commercial Applications. There's a link to the paper. These slides are available. But I just want to go over some stats from this paper because it's really, really, really scary and interesting and scary. As one would expect, 95% of all applications include some form of open source. People today don't build applications from scratch. They take components or dependencies, put them together, and they code like the 10 to 15% of their application logic using all of these components to glue to make the application work, to make it faster to develop. But but that means that a large portion of your code is not written by you, it's written by somebody else. So 60% of those applications contain open source vulnerabilities, contain vulnerabilities due to the open source components that they utilized. From the Apache struts, the Adobe XMP toolkit that I listed earlier. So 67% of the applications that they surveyed had vulnerabilities. The next one's the really shocking one, but for some of the developers, we might understand why this happens from the code's working, I've got other features to build. Why am I going to worry about upgrading something? The average age of these vulnerabilities when they did this survey was almost 1,900 days. Meaning when Black Duck analyzed the applications, they had known vulnerabilities in these applications in the open source components that they were using, and those vulnerabilities had been there for almost 1,900 days. Known, patched, long time ago. This is just a study by Black Duck, and I know they're one of the commercial people trying to sell this in this market. But if you go back and look at other research in this field, the trend is still there. I mean, if you go look at the fortune cookie vulnerability, how many people know what fortune cookie was? No? Okay. It's just another, I think it was a remote code execution, right, Tim? In routers. It was an attack against a router. And the culprit was the Nginx web server on the router. The vendor actually had patched this years ago, but the hardware providers were still embedding an old version of the web server in there, and that's why this vulnerability showed up. It's that we have something that works. Why do we upgrade? So that's one of the fun problems that us as developers face sometimes. So again, another thing, why do we care? In OWASP Top 10 2013, OWASP Top 10 is the top 10 list of the most critical web application risks. In 2013, they added A9, using components with known vulnerabilities. When this came out, they said that the prevalence of this was widespread. And again, if we look at the Black Duck study, there's other papers, The Unfortunate Truth of Insecure Libraries, and several other papers in this space. They'll all show that this is a widespread problem. All applications have old dependencies in them. And at the time, they said that detectability was difficult, that this is really not an easy problem. And in reality, I think that was for 3 to 4 reasons. I put 4 reasons here. But in 2013, it had to do with awareness. When this hit the top 10, this was the first time a lot of people had heard about this problem. And because it was the first time people heard about it, there wasn't a lot of visibility into the applications. And part of that was because there was a lack of tooling, because of lack of awareness. So there was no tooling in 2012, 2013. Since about 2012 or 2013, there are a lot of tools coming out in this space, a lot of commercial tools. Dependency-Check is one of the, well, we'll go to the next slide. Oh, wait, no, we won't, sorry. Dependency-Check is one of the leading tools in this space, but we'll talk more about that later. Okay, so next, on to patching programs. Everybody's familiar with patching programs within their organization. You know, you'll get your Microsoft Office updated, you'll get your OS updated, and they'll even upgrade WebLogic, Tomcat, and your middleware components. But they don't generally cover application dependencies. Part of that is, again, going back to the lack of awareness. Most companies don't even know don't have a list of what third-party open source components are in their applications. They don't even have an inventory of this stuff. They'd have to go back to development and say, what are you actually using? And A bigger problem is even if the patching programs did know about these things, they can't push a patch to an application. For those of us that are developers, when you patch an application, you could have code changes, you could have regressions, if you change a dependency. And so you have to go back and upgrade the component, test, make sure everything's still working the way you expect it to. Oh, yeah, sorry, I didn't flip that forward, but that's, the patching application dependencies require code changes and possibly full regression tests. So in modern times, they may not do full regression testing, they may do A/B testing or other things depending on your development methodology, if you're agile or, DevOps-sec, just pushing code all the time. But it requires testing of these changes. So then we get to OWASP Dependency-Check. I started writing this in December 2011, and I was first able to publish it in 2012 after getting clearance from a few people. They allowed me to open source this. It performs what's called software composition analysis. That's I believe, the Gartner term for looking at the dependencies within your code and finding out if they're vulnerable, but in reality, that term also applies to legal compliance. Dependency check doesn't really do much with the legal compliance. If we find the license, we'll report it, but it's not the key thing of what dependency check is doing. It really is a really simple solution to identify these known components. There's several interfaces to it, Maven, Gradle, SBT, or an Ant task. There's a command line. If you're doing continuous integration, there's a Jenkins plugin that you can scan your code with and get trending and metrics on your projects to see are the known vulnerable components getting better or worse. So currently we fully support .NET and Java. With the last release, we added CocoaPods, Swift Package Manager. We have Python, but it's a little hit or miss. These are experimental analyzers. PHP if you're using Composer, a little bit of Node.js, and a little bit of Ruby. The top three are probably going to get the most attention over the next couple of months to really try and get those promoted to be first-level citizens within Dependency Check. I know I've had a lot of people asking for those three, so I'm really happy to have gotten the help from the community in building these things out. So, how does Dependency Check work? Well, first let's talk about the vulnerability data source. We use the National Vulnerability Data, the CVE, the Common Vulnerability and Exposures Database. Huge list of all the vulnerabilities. Are most people here familiar with the CVEs? Yes? Yeah, good. So they contain a description, a score, and what's most important for us is the Common Platform Enumeration, or the CPE. So, this is kind of obvious, but to identify a library, you have to have a correct identification to be able to report on these things. Really kind of obvious. So, what are the problems with the library identification? Biggest problem is that development and security use different identifiers. Developers are really understand what the group artifact version or the GAV coordinates are. This is what is from Maven Central, Bintray, others. You can use the GAV coordinates to find the libraries and just automatically incorporate them into your application. So for Spring Framework, and I know for those that know Spring, we're actually up on 4.6 or higher, I don't today, but the 3.2 points out an interesting problem with library identification. So in security, as I mentioned, we use the CPE. And this is the CPE for Spring Framework 3.2.0. Spring Source, Spring Framework 3.2.0. But because those of us in security, we're really big on blame. We want to point at the vendor that is responsible for this. So we don't just have Spring Source, we also have Pivotal. Because Pivotal writes, actually, Spring Source was sold to VMware, or VMware bought Spring Source, and then they spun off a company called Pivotal. So of course we have Spring sources, some CVEs for the version 3.2, and then we have some that are under Spring Source and Pivotal for different CVEs. Oh wait, we also have Pivotal software because the people naming these things at the NVD aren't being very consistent sometimes, which isn't their fault. I mean, there's a huge amount of data and that they have to go through. But to do a correct identification of this library and to actually report on all of the vulnerabilities, if you were using Spring Framework 3.2.0, each of these CPEs are linked to different vulnerabilities within the NVD. So you have to be able to identify all three of them. And this is not uncommon. There's a few libraries that have this problem. There's a big issue with the Sun and Oracle libraries because when Oracle bought Sun, so pretty much any acquisition of a large, highly used library is going to cause problems like this because, as I said, security wants to point fingers. And there's no public database that links between these identifiers. So, Dependency-Check uses what I call evidence-based identification. Most of the commercial vendors have a fingerprint identification that they've come up with. The most base form of a fingerprint identification would be a SHA-1 hash of the file. Some fingerprint identification is better than others, but I don't know what each of the vendors are doing in terms of their fingerprinting. But that's how most of the vendors in the space are working. I'm using evidence-based identification. What do I mean by that? We're extracting all the textual evidence that we can from, I'm going to use a jar file, a Java jar file as an example here. So we're going to extract the file name, entries from the manifest, if there's a POM, or we can download the POM from Maven Central, we're going to extract entries from that. We're going to look at package names, basically any textual information that we can figure out who the vendor and what the product is and what the version is. We're going to take all of that information and dump it into a vendor product and version collection. And then we take a local copy of the NVD, CVE data, and we create a leucine index of the products and vendors. And then we kind of do a fuzzy search against the evidence, against this leucine index of the CPE data to do kind of a fuzzy match and figure out what the libraries are. It actually works really well. It's a somewhat unusual use case for leucine because leucine is a library used for searching large text documents, and you do, searches against them. I'm taking two keywords, making them a document in leucine, and doing searches against them. But there's a lot of features in leucine that make this work. And I've written some custom analyzers and whatnot that kind of help out. So a lot of, we then search the CPE index. So the two issues with this evidence-based identification, false positives. Sometimes the evidence extracted from the libraries lead us to point at a different CVE, or CPE rather, a different CPE. Usually, like 99% of the time when these false positives crop up, and I'll hopefully show you guys one here in a minute, they're obvious. It's something like file.jar is identified as the Solaris file system or something like that. I mean, it's just like, the false positive. However, false negatives also occur. If there's key elements that keywords that are not in the jar files, for instance, like pivotal is not listed anywhere in the 3.2 version of the Spring Framework. I've come up with a way to deal with that, obviously, but that is also a problem with this. Commercial vendors, I've also seen false negatives and false positives. Well, no, sorry. I have not seen in any of the examples false positives come out of the commercial tools. I have seen false negatives in the few times that I've seen comparisons against the tools. I don't actually have access to any of the commercial tools myself. So one of the things about dealing with false positives, and I'll show you a little bit more about this when we get into the demo, I have a suppression file that it's really simple. We can just say, give it like the GAV coordinates, the group artifact version, and say, you know, this one is Spring Security. Well, Spring Security doesn't match Mod Security, Spring Framework, or any of the variants of the Spring Framework. And so I created a false suppression file, and that's how we deal with those. On the other side, dealing with the false negatives, that's something I'm really only doing in the tool itself yet. It's not really a fully robust thing that I'm, you know, at the moment supporting other people do, but it will be documented soon on how to do that. I'm just trying to clean up a few rough edges with that. So if people wanted to deal with that problem themselves. So one of the things with when you're using dependency check is there's always an onboarding when you have to onboard a new application. And the basic steps, I mean, for the best place to integrate this is into a build system like a Maven or Gradle or SBT. Jenkins works also. So you have to configure the plugin. There is a command line interface for those of us who might be auditors or something like that, or don't have access to the build system. But in general, the best way to run it is as a plugin into the build. So you have to configure the build. Dependency check does kind of require access to the internet, so you might have to do some proxy configuration. If your build servers can't access the internet, there is documentation on how to deal with that, and basically there's documentation on how to deal with that on the documentation site. So then you'd run your initial scan, and then many times you'll have to do a quick configure a suppression file. Sometimes you don't need this, sometimes you do. It generally, once you understand how to create a suppression file, dependency check gives you all the tools to make this suppression file really quick and easy. You know, small app, 5 minutes, large app, 20 minutes, maybe, depending on how many dependencies there are. Just kind of go through them, review them. And then after you have your suppression file, you know, rerun, and then also plan the upgrade for any identified vulnerable components. That's kind of the basic steps of this. So, due to a small issue with laptops and projectors, I don't actually have a full demo of setting up and running dependency check. It's really not that exciting. It's just adding a little XML configuration to a file. So for the demo, I'm just going to open up what one of the reports actually ends up looking like. Okay, probably. Yeah, I'll go down a little bit. I want to make sure it was at least readable for people in the room. So this is what a dependency check report looks like. This report is a little bit more modern. If you went out and downloaded 1.4.3, which is available today, this is not the report you would see. I am hoping to publish 1.4.4 this weekend. So this is the report that will be in 1.4.4. It just added some help text and it modified and cleaned up a couple other things in the report. So when this report was run on actually a security library, and I have completely masked which security library this is because I have not had time to put in a pull request yet to that open source project. And I thought it would be kind of bad form to be saying, hey, look, there's a bunch of known vulnerabilities in a auth-n, auth-z platform that people are using. So I've kind of hidden that, but this was just a random project that I pulled off the internet that people use. And as you kind of go through here, you can see that we have a dependency, xstream, and that it was identified as xstream 1.4.7. It's a ThoughtWorks xstream, and let's go down and take a look at this one. It's again a serialization library, and it does look like it's a correct match. And then you can come down here and see that there's multiple external entity expansion vulnerabilities in the various dom4j drivers, dom driver, jdom driver, so throughout this library. The CVSS score is a 5.0, which is a medium severity. This is still currently using CVSS version 2. It's using version 2 because the NVD CVE data has not been updated to use version 3 yet. It might be on their website, but it's not in the data feeds that you can pull down. At least I haven't seen it yet. So it may be there, but I'll have to do an update as soon as I can get to that, but I haven't seen it in the data yet. So we also see that there's some Java mail possibilities. Looks like Apache CXF. These all are like real vulnerability or real libraries and whatnot. However, if we look at the annotations API 6.0 and it's saying that it's Apache Tomcat, well, in reality, it's not. I mean, it is. It's something used in Apache Tomcat, but it's not the actual library that everybody would say that's Apache Tomcat, you need to upgrade. In fact, I'm not even sure if the annotations API 6.0.4.1 actually links directly to the Tomcat 6.0.4.1. It might. Again, I don't know. That's one that I still have to research a little bit. But Tomcat has vulnerabilities. This library doesn't. So one of the things you can do, as I was saying, is it's really easy to generate a suppression file. And so what you can see here is the identifier is Apache Tomcat for the CPE. We don't believe that this is a correct match. And so we just click the suppress button here, and we'd get a little pop-up with some XML that shows how to do that gives you the suppression file for this. And if this is the first time that you're running this, and the first time you're creating a file, you can just hit this complete XML, and it'll actually give you it'll give you the full XML. Sorry, 1 second as I open up Notepad. Is that mostly readable for people? It's close enough. This just gives you the full XML, and then you can then just go back and find another library in here. The Hibernate is found, Netty, Remote JMX. This is probably the most obvious. This is one of those where this is the type of thing that is like just blatantly obvious. Remoting JMX is not the Mac OS. I mean, some of these are just really obvious, and it's just because there's keywords in the evidence, because you can actually see all the evidence here. There's keywords that had Mac somewhere in the evidence, and so it got flagged as the Mac OS X. And so again, we can just come in here, click suppress, little pop-up will come up, you hit Control-C, it copies it into the clipboard, and then you can go to your suppression file and just build this out for your, did that in the wrong place, didn't I? and then you can just slowly build out your suppression file for the application. And then you'd save that, and then you can just add the suppression file to the configuration. But that is pretty much the report. One of the things that I've found is when people look at this report, and I ask that if you use this tool, please, if you see false positives, report them back to GitHub. You can just use the link here to get to the GitHub issues. If you have questions, you can go to the Google group. But one of the things I've found is that people tend to report that there's a specific false positive for this library for this CVE, and that causes a lot of research for me because it's generally not a false positive for the CVE, the Common Vulnerability Enumeration. It's a false positive for the Common Platform Enumeration. So please, when you're reporting issues, please say Common Platform Enumeration is a false positive. So that is kind of the report. And again, I am trying to find time to go back and give the security library a pull request to maybe fix a couple of these. Oh, one other thing I forgot to show you guys. And this is a great example. This is actually a multi-module build. So it's actually has like 70 different modules in this application. And when you're trying to figure out, hey, where is this jar used in a large application, we do list all the different the different locations that library is used. So all of these modules within this framework will probably need to be fixed. So the other thing about that, well, no, actually, we'll just jump back to the slide deck. Okay, so what are some of the use cases for dependency check? Well, in your organization, you can use it to prove the existence of this problem in your applications. You can run it, and just because you can show people reports from like Black Duck and others, but until they see a concrete example of how this is affecting their applications, they may not listen, and you may not be able to get funding for a project to deal with this problem. Another use case that I've seen people where they've used dependency check is kind of a baseline when they're doing a POC with a vendor. You know, the free tools out there, if they're doing equally as well as the vendor, you know, I mean, there's a little bit of manual work because of some of the false positives that crop up from a dependency check. But I know several companies that have opted not to go after a commercial vendor, a commercial solution, and yet, on the other hand, I do know others that have used dependency check, seen it, saw the value in this, or seen the problems that have been identified in their software, but for whatever reason, corporate culture, they want to use a commercially supported tool. Totally fine, totally fine. I'm just saying, just use it as part of your baseline when you're looking at this, just to kind of see what the difference between what you're getting from from dependency check versus what you're seeing with the commercial tools. And like I said, I know several companies that are using this as their primary tool to identify known vulnerable components. There are several companies, and if you go look at some of the issues and whatnot within the GitHub repo, you might be able to figure out who some of those companies are. Not all of them, but some of them. And it's actually interesting to see the size of some of the companies that are actually using this. So one of the things I want to talk about is also a problem that crops up a little bit is when people want to start out with an enterprise deployment. One of the problems that we've seen when people try to deploy this across a larger enterprise is each individual instance, by default, will maintain its own copy of the NVD CVE data. And in some cases, the build servers or where these things are being done don't have access to the internet. And so what they've done is they've stood up a real relational database and pointed all of their dependency check instances at that single database, and then just have a single node that's able to connect to the internet that's used for updating the database. Again, if you have Nexus running internally, by default, dependency check, when it sees a jar file, it will go ping out to dependency check to see, ping out to Maven Central to see if that jar file exists, or EAR or WAR file exists in Central. And it may pull back the POM if it doesn't have one to extract some additional information from it. If your build servers can't reach Maven Central, you can, and you are running a Nexus server internally, you can configure dependency check to hit a Nexus server. We are looking at expanding to other binary repositories that people have in their environments, but at the moment, Nexus is the only one that we have supported. There is an open ticket to add Artifactory, but we haven't gotten to that one yet. Usually, people are running in larger organizations, they're running this within their CI. And then it just allows them to do continuous monitoring and reporting on their libraries. There's actually an OWASP Dependency-Check Sonar plugin, so if your development teams are using Sonar, which is a kind of a quality tool that a lot of development teams use, you can feed these vulnerable components directly into Sonar, and you can treat them just like code quality. You can fail a build if there's vulnerabilities found, or you could fail a build if the vulnerabilities are above a certain threshold. So if I find a library that has a CVSS higher than 7, I could fail a build, but I'm going to allow the lower risk ones. Not necessarily a good idea, because sometimes those lower risk ones add up to a bigger exploitable problem. But you can start treating your vulnerabilities or your vulnerable dependencies as code quality. Lastly, just to touch on governance a little bit. As I said early on, the known vulnerable dependencies are only a small part of the issues with using FOSS and in your organization and software and the software composition problems. A lot of it has to do with legal, is another huge risk. Are these things AGPL, GPL, BSD? If it's BSD, is there a patent clause that goes along with it, such as the React.js library has? Those are interesting questions that you'll want to talk to your legal team about. Should we be using React? I know, I know many companies do, but I know a few companies have decided that they won't use React because of that patent clause. And that you can look that one up on the internet if you want. In general, you should control what, if you're in a larger organization, you absolutely should be controlling what is being brought in terms of open source. You want to have develop some kind of process that includes architecture, legal, and some level of security review. There's reasons for each of these components in a governance program around open source, and I'm only touching on this. This is at least 1 hour, a 1 hour talk just to cover this topic. But in general, if you do set something up, really try and make it easy to engage. Otherwise, you will find development teams trying to circumvent it. Yeah. Yeah, it's truth on that one. Because I've seen, in talking to some peers at other organizations, I know that they've had an issue, particularly in the JavaScript space, because they're doing really, really well at controlling, .NET assemblies through NuGet and they have their Nexus for all of their jar files or whatever. But then the JavaScript libraries, the developers just go download them and put them right in the app, and nobody knows that they're using, whatever library it is. And there could be vulnerabilities in it. It could be an architectural decision that your team, or from an organizational standpoint, you don't want to use Backbone. Maybe you want everybody to be using Angular, so from a JavaScript standpoint. And so that's why architecture needs to be involved in this. And the security is obvious to hopefully everybody here, and also the legal with the licensing issues. So, any questions about dependency check? Alex will be bringing a mic over.
The false negatives.
It's just for recording.
Okay. Oh, the false negatives. Is the cause of the false or the false negatives, is that because of a misidentification in terms of it identifies one library has something else in the CPE, or is it because of an unknown identification? It can't find a CPE to identify with. And is there a mix? Do you have a percentage if either one of those?
Unfortunately, just give me 1 second to get to the right page here. Okay, so the library identification problems page. One of the areas that we might get false positives from is if you look right here. If we didn't, well, actually I can show, if I hadn't already tuned the engine to know that if I see Spring Source, Spring Security, I'm going to add Pivotal and Pivotal software. That's just a hard-coded solution that I had to put in there. Because nowhere in the 3.2.0 version of the Spring Source of the Spring Framework library is Pivotal mentioned. Because when 3.2.0 came out, Pivotal was not even on the roadmap, really. It was still Spring Source. Well, it might have been on the roadmap because I think 3.0, but you can see where those kind of crop up. And so if the jar file doesn't have the information, doesn't have the word Pivotal anywhere in it, it's not going to be identified. From a lot of the bake-offs that people have told me about, again, I have not done any bake-offs myself against any of the commercial tools, but from ones that people have shared with me, actually works really, really well. And that's why we've been keeping the program going, is that it really has been finding, for the most part, everything that the commercial tools have been finding. In one instance, I know they scanned about 1,500 jar files, and I won't say which the commercial tool in this case was, but they found one vulnerability that dependency check did not. And that one vulnerability was identified because it was listed in the OSVDB, the open source vulnerability database, which has been closed down, and now it's the VulnDB from Risk-Based Security. They were the custodians of OSVDB, but they just couldn't maintain that database in an open standpoint anymore from a business model. So they closed that one down, but the data is still available in the subscriber-based VulnDB. So they had one vulnerability because they had data sources available to them that I did not. That's going to be the biggest place where you will find value from the commercial vendors, is because they have a lot more vulnerability data, especially Black Duck and SourceClear. I don't know enough about the other companies to know what their depth of vulnerability libraries, but SourceClear, SRC:CLR, they are doing a lot of interesting research in this area and identifying new and interesting vulnerabilities. So does that kind of answer your question about where these things crop up?
Well, I was just curious about, well, I probably should have started off with what is your false negative
That is a fantastic question. I have no idea. I'd love to know, but
it sounds like you believe it's pretty small.
It's small. They do crop up. We did have an issue with Hibernate, the Hibernate validator, and somebody pointed out, and I've done some things to correct it as a temporary patch while I work on a larger solution. Unfortunately, that temporary patch does cause some other false positives, but I'd rather have false positive than false negatives. And we're working always on improving it. As you know, security people tell us that, hey, we missed this thing, great, I'll figure out how to tune the engine. If they're telling us that there's false positives, I'm going to figure out how to tune the engine. In many cases, it's just a one-off patch for a specific false identification. In other cases, I've actually changed the engine substantially to just eliminate that class of false positive. So it varies on what's happening, but it seems to be working fairly well. The other thing I want to touch on is in that analysis of the 1,500 jars, Dependency-Check had something like 50 to 100 false positives. So, I mean, it's not a low false positive rate, but that was an early version of Dependency-Check. It's been improved a lot since then. But we also found 5 vulnerable libraries that the commercial library or the commercial tool didn't.
Okay, I have another question, if that's okay. On the report, I may have missed this, but did you show on the report all of the libraries that were processed?
Yes. Here, I can. Okay, that's the one thing is at the top here you can see there were 504 unique vulnerability or libraries that we scanned. This list right here is only showing the vulnerable libraries, obviously, because it's only, it's a 22 of them were found to be vulnerable. If you want to see all the libraries, you can click on this Show All, and it will expand and show you everything that was there. There is an XML report. That XML report does include all of the vulnerabilities, and that is where a lot of people use that XML report to feed into other systems. One of those other systems would be like ThreadFix from the Denim Group. It's one of their open source, well, there's a community edition, but there's also an enterprise version of it. But you can actually upload the findings from Dependency-Check right into your, if you're using ThreadFix, into that vulnerability management platform.
Thank you.
Jeremy, could you speak a little more about comparing with some of the commercial tools? Where are some of the overlaps, and then where are some of the things that you feel like your tool is really the sweet spot for that?
Well, there's a lot of things that the commercial tools do that Dependency-Check doesn't. But again, I don't actually use I don't use the commercial tools. I don't have access to them. This is actually something. This is not sponsored by my day job. If you guys look up where I actually work, this is not sponsored by my day job. If you go out and look in GitHub and look at the commit times, you're going to see that they generally occur between 5 a.m. and 7 a.m. Eastern Standard Time. Because I get up at 5 a.m. to code on this at Starbucks, and then I go home about 7 a.m. when my wife and daughter wake up. So that's when most of the work happens on this. So some of the code's a little, might because I hadn't had enough coffee yet. Where some of the commercial tools will do better is they have almost all of them have a large centralized reporting platform that can be used to monitor all of the compliance within the entire organization. Many of the tools actually came from a legal compliance background, in particular like Palameda and Black Duck, so they're going to do really, really well to help with that compliance issue. Dependency-Check doesn't do anything in the compliance. I mean, it'll list the library if it's in an obvious place, but best effort, I can't guarantee that that's right. I mean, it's obvious in that it has that the license.txt was in the jar file, but that's about all I can tell you. So the centralized thing, or the centralized portal is great. Another one is that they have vulnerability data sources that Dependency-Check doesn't. So either they've paid for access to commercial vulnerability repos where other researchers are putting things, or they're doing novel research themselves to identify known vulnerabilities. And that's probably the biggest benefit of the commercial tools, those two line items. Do you have more questions or want more depth on that, or is that good?
That covers it, thanks.
Good deal. I think.
So based on the dependencies scanned, is that suggesting that there's 365 dependencies that aren't unique, and are they duplicate code?
What do you mean 365?
And the
Oh,
dependency scan.
okay. The difference here is there's 300. If you take the 869, subtract the 504. Where that comes from is that Jackson Core is used in many, many spaces. It was actually we counted that as being scanned once from each of these locations, basically, that we're showing. And that's how you get up to the 806, because it was identified in a different module. In other cases, like if you're using the command line tool, generally this doesn't show up to be different when you're using the command line tool. But the times that it would, because you might have a jar file existing in multiple directories, or the same jar file might be, like you might scan a war file and the expanded or the exploded war, and so you'd have the dependency check does dig into archives, and so you'd have one dependency from the war file where the library was, but if you also had the exploded war right next to it, or it's the zip file expanded out, you might also see the library in the directory structure, not in the war file itself. So you might find it in both places. Is that good enough? Other questions? No? Good deal. Hopefully this was interesting to people, and hopefully you'll at least go out and, oh, one last thing that I really should talk about. So I just thought about this one. If you notice on the languages supported, you'll notice one thing that's not really very well on here: JavaScript. That is another area today where commercial tools will do better than dependency check. We're not doing anything to identify a vulnerable version of jQuery. We're not doing anything to identify a vulnerable version of Angular. There is another project, another related project called retire.js. For the people that I know that are actually using dependency check, they're usually using dependency check in combination with retire.js, because retire.js does help identify some of the vulnerable JavaScript libraries. I always forget, I can't believe I forgot to put that in the slides. So with that, I hope everybody found this useful, interesting, and thanks for listening to me for an hour.